So we've got a problem here that actually gives us the answer, right? The problem is talking about something that's really cool, an ultracentrifuge. Now, centrifuges are a medical and an industrial application of using the spin of something. And what it does is it separates particles of different mass. So this is a super speedy one. It's got a radius of 0.1 meters. It's about 10 centimeters. And it's spinning at 50,000 revolutions per minute, which is crazy fast, right? So we've already kind of talked about the Earth and its orbit. So we know that the distance between the Earth and the Sun is 1.5 times 10 to the 11 meters. And we know that the orbital velocity, right, is just 1 revolution per year. Not very fast, right? The question asks us to confirm some numbers that it gives us for the linear velocity of the centrifuge and the linear velocity of Earth. And something really cool happens. So we only have one equation, right? It's just the relating linear and angular velocities. Okay? Before we do this problem, though, we've got to get these angular velocities into our standard units. So you put in 50,000 revolutions per minute, and you convert that to radians per second, and you still get something that's pretty speedy, right? It's 5.2 times 10 to the third radians per second. Then when you do the angular velocity of Earth, it's tiny, right? You put in how many seconds there are in a year, and you get that it's 2.0 times 10 to the negative 7th radians per second. So that sounds even slower, right? However, when you put it in your formula for linear velocity and angular velocity, you discover something kind of crazy. You discover that even though 0.5 kilometers a second is pretty fast, right? Plug it in. You get that the Earth is hurtling through space with a linear velocity of 30 kilometers a second, which is crazy fast. So I hope that this helps you work some of your problems, and I also hope it helps you think about orbits and how fast we're moving around the great ball of fire that is the sun. I hope you enjoy working your homework problems. Good luck.